Hello everyone, so welcome to part 2. We're continuing on with problem number 6 on the test review. So in this one we have 9% of people being left-handed and we select 7 at random. So we want to know how many lefties you expect. So we want to remember the formulas for the binomial scenario. So for a binomial distribution, the mean is n times p, and the standard deviation when we're trying to compute that is the square root of n times p times q. So what did we say? We said 9% and 7 at random. So the mean, if we want to do that in this example, will be 7 times 0.09, which comes out to 0.63. And the standard deviation would be the square root of 7 times 0.09. And remember, Q is the complementary percentage, so it makes it add up to 1, so that would be 0.91. So when you do that in the calculator, let's see, the square root of 7 times 0.09 times 0.91 comes out to, I don't know how many decimals they're going to ask for. I'll write down 4 right here, 0.7572. So let's see if we can get back to the question. All right, so how many lefties did we expect? 0.63. All right, and what was the standard deviation? That's how many decimals? 2, so that'll just be 0.76 for us, rounding to the second decimal. All right. And then if we keep picking people until we find a lefty, how long do you expect it to take? Well, we did this one in class, I believe so. The formula for this, the expected value until you find one, it just comes out to, we're doing 1 divided by 0.09. Sorry, I had to pause my video for a second. It said my mic stopped working. But 1 divided by 0.09, this comes out to 11.1 repeating, so about 11. We'll see how many decimals they ask for. So 2 decimal places, so that's just going to be 11.11. All right. So assume 13% of people are left-handed. Suppose 10 are selected at random. Answer each question about right-handers. So here, it's the same thing, but they give you the complement. So if 13 is the percentage of left-handers, 87% is the percentage of right-handers. So, so to do this again in this scenario, here NP, so mu, which is NP, this is going to be it was 10 was the sample this time, and 0.87, so that comes out to 8.7. And for the standard deviation, if they ask for it, that's going to be the square root of 10 times 0.87 times 0.13. So let me do that quickly on the calculator. Square root of 10 times So I'm a little bit slow here. I'm using a calculator I don't typically use, and the buttons are just in slightly weird places. So this comes out to about 1.603. So the mean was 8.7 for right-handers. All right, hopefully they ask for the standard deviation next. Yep, there we go. 1.06, they just want 2 decimal places. All right, moving right along. Probability that they're not all right-handed. So, probability that they're not all right-handed is exactly the complement of them being all right-handed. So essentially we can do that by saying, okay, probability of all right is going to be exactly one. Sorry, the probability that they're not all right. So actually, I'll just write not up here. So probability that they're not all right is 1 minus the probability that they're all right-handed. So the probability that they're all right-handed is actually pretty easy to compute because the chance that one person is right-handed is 0.87. So to get all 10 to be right-handed would be 0.87 to the 10th power. So 1 minus 0.87 to the 10th power is going to be your answer here. So that comes out to be 0.7516. So how many decimal? 0.752 is what we're going to get. And I'll finish there. Oh, one more part. What's the probability that there are no more than 8 righties? So again, we could do this one by hand, but also we can do these using Statcrunch. So let's do this one using Statcrunch. So we go to question help. Actually, Statcrunch is already opened, isn't it? Yeah, we have Statcrunch open over here. We're going to use a different calculator. This one is the binomial model. So we go to calculator, then binomial. And we're going to use the binomial distribution with n, the sample 10, and then right-handed is 0.87. And we want the probability that there are no more than 8 righties. So 8 or less is what we want the probability of. So this is 8 or fewer. Click compute, and it gives us that probability right there. So 0.380 is what we'd enter. And we're all set. All right, what's the probability that there are exactly 5 of each? Again, we could do that on Statcrunch. We just change the value here to equals and change the number to 5. So the probability you get exactly 5 is 0.004, they want 5 decimal places, 66. So 0.00466. So doing that by hand would be a little more painstaking. We'd have to use the choose function and all of that business, but Statcrunch makes it a little bit easier. Okay, we still have one more part on this one. So what's the probability that the majority is right-handed? So that means more than 5, which would mean 6 or more. So probability that you get greater than or equal to 6. So compute that. We get 3 decimal places, 0.995. All right, so all set with that question. So this one, another binomial example, I believe, but they don't give you directly the probability. They say it averages 1 in 4, which means 0.25. And they collect 230 frogs. So your mean is 230 times 0.25, which comes out to 57.5. And then, as before, the standard deviation will be the square root of 230 times 0.25 times 0.75, which is 6.57 if you round. All right, and when is it appropriate to model a binomial distribution by a normal? Remember, the condition is NP and NQ both have to be greater than 10, and NP is the mean right here, 57.5, and if you did 230 times 0.75, it would be even bigger than that. So yes, because they're both greater than 10 is the appropriate choice. All right. The biologist found that the trait was in 62 of his frogs. Does this prove that the trait has become more common? So essentially they're asking, okay, is it farther away than 3 standard deviations from the mean? So that's really just asking us to compute the z-score of 62. So we're going to do 62 minus 57.5 divided by 6.57. So this is exactly what we did in the second example. So we do 62 minus 57.5 and then divide that result by 6.57 and we get about 0.68. So does it prove the trait has become more common? We'd say yes, because it's within 3 standard deviations. Oh, did I botch up the z-score? Oh, so sorry. It's no. It's not more common. So yeah, it hasn't changed because of that. So it should be no, because it's not more than 3 standard deviations from the mean. Sorry, I just read that backwards with all the knots in there. All right, moving on. So this one, again, another binomial where we're computing the mean. So 13% of his phone calls is what they say he should average sale on for this telemarketer. In the first week, he called 300 people, but made only 10 sales. So should he suspect that he was misled? Well, 13%, 300 people. We're trying to find the z-score for 10. So let's do that again. So I'll write it down one more time. So the mean mu here is going to be 0.13 times 300. So that comes out to 39. And then we are computing the z-score for 10. So this is going to be 10 minus 39 divided by, oh, we forgot the standard deviation. So the standard deviation would have been the square root of 300 times 0.13 times 0.87. So the standard deviation here is let's see, that is 5.82. So that's what we divide by for the z-score. And that's going to give us some negative number. So negative. So all right, divided by 5.82. Let's see what this value is. So we get negative 3.26. So we're farther away from 3 standard deviations. So that is a pretty unlikely event. So we would probably say that we were misled. So 10 sales is more than 3 standard deviations below the mean. So he was misled. Okay, so I think I'm going to jump off here and I will do the last 3 parts, their last 3 questions and the third part of the video. So stay tuned.